If you've watched the earlier videos in this series, you're already familiar with an overview of the nutrient balance sheet concept, you know how to calculate net crop requirements, and you know how to calculate balanced manure application rates to meet the N, P, or K requirements of the crop. So now let's talk about selecting a planned manure application rate. The planned manure application rate needs to be a rate that the farmer can achieve with their spreader. Many farmers have spreaders where the application rate depends on the tractor speed, the PTO speed, and some gearbox settings on the spreader. They should have a few application rates that they know they can spread at given different combinations of these factors which they've verified through a manure spreader calibration process. So the planned rate that you use in a nutrient balance sheet should match one of the calibrated rates that the farmer has. On more modern spreaders, such as those that many commercial haulers use, the application rate can be regulated automatically through computer control of valves and belt speeds. It's as simple as typing in the desired application rate into the rate controller. If you're working with equipment like this, you obviously have much more flexibility in selecting a planned rate. One thing to be aware of is that it can often be difficult for manure spreading equipment to achieve very low application rates, such as less than 2,000 gallons per acre for liquid manure, or less than 1 ton per acre of poultry litter. Achieving these low rates requires driving very fast over the field, and there's a limit to how fast we can go in many Pennsylvania crop fields where we have rolling terrain, short fields, and lots of groundhog holes. The next consideration in determining a planned rate is knowing whether the situation can use an N-balanced manure application rate or whether it is constrained to a P-balanced manure application rate. In most cases, applying an N-balanced manure rate will over-apply P, and the regulations in Pennsylvania each have certain guidelines as to when an N-balanced rate that over-applies P can be used. In Act 38 nutrient management plans, N-balanced manure application rates can be used when P-index Part A questions are all answered as no, or when the P-index Part B score is less than 80. In manure management plans and Act 49 nutrient balance sheets, N-balanced manure rates can only be used when soil tests are available and the melic-3 phosphorus level of the soil test is less than 200 parts per million. If none of these are the case, then the manure application rate is constrained to a P-balanced rate. So your planned manure rate must be something that can be achieved by the farmer based on their calibrated settings, and if you're allowed to use an N-balanced rate, then the planned rate must be less than or equal to the calculated N-balanced rate. If you're constrained to use a P-balanced rate, then the planned rate must be less than or equal to the calculated P-balanced rate, as well as being less than the calculated N-balanced rate. Based on all of these factors, choose a planned rate to use. Let's take a look at the example nutrient balance sheet that we've been working on, and say that the farmer has calibrated application rates of 8,000 gallons per acre and 4,000 gallons per acre. We have a soil test and the melic-3 P level is 45 parts per million, which is less than the 200 parts per million we need so we can use an N-balanced application rate. Comparing our calibrated rates to the calculated N-balanced application rate, 8,000 gallons per acre is above the N-balanced rate, so it would be applying excessive N and shouldn't be used. Instead, we have to use the 4,000 gallon per acre calibrated rate. Let's enter that rate into our balance sheet. Once the planned rate is selected, we need to calculate the available nutrients that will be applied with that rate. This is fairly straightforward. Just multiply the planned application rate by the available nutrients in the manure. For our example here, we have 4,000 gallons per acre of manure applied times 9.94 pounds of available N per 1,000 gallons. The units cancel out, and don't forget to divide by 1,000 to get 40 pounds N per acre applied after rounding. For P, 4,000 gallons per acre times 12 pounds P2O5 per 1,000 gallons is 48 pounds P2O5 per acre applied. For K, 4,000 gallons per acre times 23 pounds K2O per 1,000 gallons gives 92 pounds per acre K2O applied. We enter the nutrients applied at the planned rate into this row of the balance sheet. Now we need to calculate the nutrient balance at the planned rate. This is simply the net nutrient requirement for the crop minus the nutrients applied at the planned rate. we needed 60 pounds of N per acre, and we applied 40 pounds of N in the manure, so we are left still needing 20 pounds of N per acre to meet the crop needs. For P2O5, we only needed 20 pounds P2O5 per acre, and we applied 48. 20 minus 48 gives us a negative 28. The negative indicates that we applied 28 pounds more P2O5 than was needed by the crop. For K2O, we subtract 92 pounds K2O per acre from an already negative 10 K2O in the net crop requirement, for a total negative of 102 pounds K2O per acre. The negative indicates this is an excess amount of K2O applied. Once we have our nutrient balance at the planned rate, we can see if any supplemental fertilizer is needed. The only positive nutrient balance we have in this example is for nitrogen, where 20 pounds N per acre is still required to meet the crop needs. We can meet this need with supplemental fertilizer. Since P and K balances are already negative or excessive, there is no reason to apply any additional fertilizer. We put the amount of supplemental fertilizer that will be applied, in our case 20 pounds of nitrogen, in the supplemental fertilizer row of the balance sheet. Finally, we calculate the final nutrient balance by subtracting the supplemental fertilizer applied from the nutrient balance after manure application. Here our final nutrient balance for N is 0, and our nutrient balances for P2O5 and K2O are negative or excessive by 28 pounds P2O5 and 100 pounds K2O per acre. And now our nutrient balance sheet calculations are complete. These videos have taken you through the steps of the calculations in a fairly basic example to familiarize yourself with what we need to keep track of. The last thing I'll say in this video series is that I strongly encourage you to work to understand the fundamental concepts of developing a nutrient balance. Don't just rely on the nutrient balance sheet template for walking you through the calculations without really understanding what's going on. You never know when you might have to develop a balance sheet on the back of an envelope or even on a napkin. Just knowing what you know in your head and using some tables from the agronomy guide. Knowing how to keep track of the nutrient balance in a crop field is one of the key skills that will make you an excellent nutrient management specialist, agronomist, or farm manager. So keep up the hard work, and I look forward to seeing you out in the field being a good steward of nutrients in the landscape.